So I'm going to turn back these quizzes and then we're going to practice for another one. Brittany, you need to keep your chair back away in case that thing comes down. I emailed.
Lift your right leg up.
I know.
Okay.
It's on this side. It's on the right side.
Right?
But if you lift your leg up, like you can feel it. Or if you like lay flat on the ground, bring your knee to your chest.
Sean, you're give me an appendectomy right now. You know so much.
I mean, I just like that shit started all the time. I mean,
Too bad you're not dead.
I know, I agree.
I'm feeling generous. Who wants to come?
Drew, you got to sit somewhere else. We'll break that thing down.
So you're gonna pick up the school, and then you're gonna get a whole assault. You're like, who do you think it was? And you're like, probably not.
So this is gonna take jump pieces.
Wham. He's suspending it?
He's like taking straight to warm with their hand.
Why?
I need to do it. Boy, you
That's so extra.
Mr. My chat was like, oh, it's in your sport.
Oh my God, Tony.
He said, you silly stringer.
This is what I'm
I was cracking it in the side.
Okay, good.
Good.
I know.
Good.
I was like, I'm just careful.
What's good?
I got that right by accident.
You did get it right by accident?
No.
Then why is that good?
This is for, do I get the bonus even though I took on Sunday?
Oh.
Give it to me.
What I get?
You went to see the Oh my God, you're so close.
That's a -2. I've been to like, what's 8?
What is this out of?
30.
Oh, okay, cool.
Mic drop. Wait, what's it out of?
No pop today?
Apparently not.
I'm taking a pop quiz.
What's your pee? Yo, he took the easy one.
Ruben, you should like do that next time.
I know. I'm going to do it. Here you go, Dylan.
He holds it for like 8 seconds too. It's like, he goes,
Okay.
It fixes money.
Alright. So we have our text.
I'm going to take all 3 of them. I'm going to give you one.
And now it is time to do a quick review and practice. Because tomorrow we have another quiz.
That's crazy, bro.
Test today?
over what?
I'm pretty sure we have.
Over what? The Lindbergh. It's the last thing we had econ.
No, it's like over the chart.
The Lindbergh baby.
What?
Lindbergh's baby. The Lindbergh.
Yeah, Alex, the last thing we did in econ class. His story.
His story, his long story that took up the whole period for us.
So here we go. A little bit bigger.
Right.
Everybody get one? Alright, so here we go. We are practicing. So,
Oh, bad. You give us all part B. That's easy.
See.
alright, so here's the deal, guys. We're either going to shut up and come to order, or we're not going to practice. Alright, we have a lot to do. We do not need to waste time practicing if you don't need it. Thank you. So, now, letter A. A plus B. Can't do it. She is exactly right. The rule for addition is they must be the same size. If they aren't the same size, you can't add them. A and B are not the same size. A has what dimensions?
2 by 2.
2 by 2. B has what dimensions?
3 by 2.
2 by 3. If they're not the same, you can't add. B, 2A. I think you can do that one. What does 2A equal? 2, 4, 6, 8. That's it. When you do scalar multiplication, remember that word is called a scalar. When you do scalar multiplication, you just take that number times everything inside the matrix. That's like a distributive, a big distributive property. John, take your hood off, please. A times B. Can we multiply A times B? Sometimes you can and sometimes you can't. Can we multiply them in this case?
Yes.
Yes, we can, because, as you already said, A is 2 by 2, and B is 2 by 3. And the rule for multiplication is these two have to match. They do. So my answer will be a 2 by 3. Okay? Now, here we go. Remember when we multiply, it's row by column. Okay? So we take the numbers in the first row, which are 1, 2, and we multiply them by the numbers in the first column, which are -1, 0. So I multiply and add, and it looks like I get -1.
Yes, ma'am.
Now I'm going to put a number in this spot, which is row 1, column 2. So I'll take my row 1 numbers, and then my column 2 numbers, and do my multiplying and adding, and that is 7. And then row 1, column 3. That looks like 8. So far so good, everybody? Now we're moving to the second row. So now I'm going to use my second row of numbers, which are 3, 4 times -1, 0. 3, 4 times 1, 3. And 3, 4 times 4, 2. So in other words, I have to take my second row and multiply it times first column, second column, third column. So what do I get? Looks like -3 and 50 and 20. Tomorrow you have to do that all by yourself. Anybody have a question about one of those numbers? All right. Problem D says we're going to add matrix A to 2 times matrix D. Now, before I get too far into this, can I do that?
Yeah.
Yes, because they're both 2 by 2s. So I'm going to have matrix A, which is 1, 2, 3, 4, and I'm going to add that to 2 times D.
2, 4, -2, 10.
So 2, 4, -2, 10, as Brittany said. Is that right?
Yeah.
Now, when I add matrices, I add corresponding parts, right? So I had like spots, the numbers in the same spot. So that would be 3, and then 6, 1, and 14. There is your answer. Anybody have a question about that? C times B. Now before I get it all written down, what are the dimensions of C?
2 by 3.
That's a 3 by 3, and I'm multiplying that times B, which is,
2 by 3.
whoopsie daisies, these don't match. So that problem, problem E, is a no can do. Because when we multiply, those inside dimensions have to match, right?
Right.
Okay. F. A A minus D. Is that doable? Am I going to be able to subtract matrix A minus matrix D? Yes, I am. So here we go. The answer will be subtract corresponding spots. So 1 minus 1. 2 minus 2. 3 minus negative 1. 4. Thank you, Mr. Landeros. We're not sure. We put a pillow down there in case it fell. Jerron was tall enough to look up there and he thinks the screw is missing. You want to here, stand on a chair that doesn't move.
No, I just need to get the screw, which I can get. So,
We looked on the floor and couldn't find it.
Was that you?
Here's a chair that does
I'm gonna go get a ladder. Yeah, we just need one screw. I'll go back and get it.
Okay. Thank you. Okay. Be careful on this one, guys. 3 minus negative 1 is 4, and 4 minus 5 is negative 1. Guess what? There's a backside.
Oh, hey.
I saw that.
Good. You know.
Now, on the back is what we talked about yesterday. These are the determinants.
Those lines that are cool.
So problem A.
1 times 1 times 1 is 1.
Well, wait a second, Hannah, let us catch up. Here's the problem, and we remember that to evaluate a 3 by 3 determinant, we do what?
Copy the first 2.
Copy the first 2 columns. So 1, negative 1, 0, and 4, 1, 1. So we copy the first column, and then we copy the second column. Then we start right here, always, always, always right here, and we multiply 1. And we multiply 0. And one more time, 0. So all of that, all of this direction right here, all of this multiplication ends up being 1. Then we turn around and go the other way. So this is 0.
Oh, wait.
This is 2. And that is negative 4. So when I add those up, I get negative 2. Then what do I do with those last 2 numbers? I subtract them. So 1 minus negative 2 is 3. My answer is 3. Okay? And then the next one. The next one is a little one. What's the answer to this?
5.
Exactly. 3 minus negative 2, so the answer is 5. Very, very good. Now, on the quiz, these problems are written like C. In other words, I didn't write it out for you. It says the determinant of C. So we got to go back to the front side, and we are finding the determinant of matrix C, which is this. Okay, everybody get that? Because on the quiz tomorrow, it's going to say determinant C. And you're going to have to know that it looks like that. Everybody got it?
Yes, ma'am.
Okay, let's recopy those first 2 columns. And let's figure that out. Hurry. See if you can get it done. We got other stuff we need to do today. Let's get these determinants done. 0 plus 1 plus 12. I got 13 on the way down. 0 4 -6. I got -2 on the way up. When I subtract those two numbers, and remember it is a subtraction, the answer is 15. One more, and we're done with this guy. The determinant of B. What about the determinant of B?
Can't do it.
Can't do it. Why can't you do it?
It's not a square.
It's not a square. Remember, you can only find determinants when the matrix is square. If it's not a 2 by 2 or a 3 by 3 or a 4 by 4 or 5 by 5 or 6 by 6, you can't do it. Okay, there's no determinant unless you are square. All right? So, Jake, you ready for the quiz tomorrow?
I'm ready right now.
Okay, we know what's on it. All right.
We're taking it right now.
No, we're taking it tomorrow.
Can we take it today?
No, tomorrow you have every period.
Oh my
Oh,
god.
what?
We have to go through
Reconciliation, you know?
Oh, hell no.
That's a good nap time. Dylan, did you take a nap?
Go take a nap. That was a long time
Oh,
ago.
it was me, Evan, Presley.
Yeah, stop it. All right.
Is the eating lunch?
Open up your notes. We have a little more work to do in our notes.
Resource.
We are on the back of page 45. Oh, I happen to think of one thing. This is not on the quiz, but I want to go through Cramer's rule with you again, just to make sure that you remember how that works. So the problems on the quiz are like the problems that we just practiced. But yesterday we also talked about Cramer's rules. And with Cramer's rule, I don't have to rig anything. I can just slap numbers up there because remember, with Cramer's rule, I don't need to worry about arithmetic. The answers might turn out to be awful and it doesn't matter because I don't have to deal with them. So, who remembers how to do Cramer's rule? Shelley?
Don't you write all the x's down like in the determinant? So we 3 on the right, yeah, and then -7.
Yep. So those are called the coefficients. These are the x and y coefficients. This is Cramer's rule. It isn't on the quiz, but it will be on a quiz after that. All right? Got it?
-14 minus
Now we figure out what that is. So it's -14 minus 9. Oh, good grief. It's -23.
on bottom.
Remember, that number is the denominator for your x and your y values. So x and y are both going to be over -23. All right, so here we go. What are the numerators? They are other determinants, right?
5, 1,
Cut these out, cut them out, and paste them or substitute them in for either the x column or the y column. So nothing changes here. You're going to take that and smack them right down there. So that is going to be 5, 1, 3, -7. And it goes in the numerator of the letter that you covered up. So if you put the 5, 1 on top of the x's, that's your x. If you put the 5, 1 on top of the y's, that's your y. Now we evaluate it. So what have I got up there?
-35 minus 3.
-35 minus 3, -38. So your x value is 38/23. That's awful, but we don't care because we don't have to deal with it. Now what about my y value? 2 minus 15. That's negative 13 over negative 23, so that's 13 23rds. And that's the answer to the question. Just like on your quiz, you got 2 comma 1. Well, now we've got this. Okay? That's Cramer's rule. Remember that from yesterday? All right, good. Now, finally, I'm ready for the back of page 45. The back of page 45. We haven't finished that. Well, Cramer's rule was out of order. So we got to do the inverses. We haven't done the inverses yet. So we're on the back of page 45. All right. So today, Brittany, today our goal, Alice, Gabby, today our goal is to find the inverse of a 2 by 2 matrix. We are not going to find the inverse of anything bigger except with our calculator. By hand, we're going to find the inverse of this matrix. Now, it is a 2-step process. I don't know how you're going to remember that, but every time you see this notation, that means inverse, and I need you to think about 2 steps. I've graded an awful lot of these papers over, lots of years, and it seems like kids always remember one of the steps and they forget the second one. Got to have both pieces to get full credit, okay? So here's how you do it. First step. We are on the back of page 45. Now, the first step, you already know this one, find the determinant. What is the determinant of this matrix? 5 minus negative 2, so 7?
Wait, is this the thing you talked about in the calculator?
No. No. Put that away. That's the first step. You already know how to do it. That's easy. Now the second step is you create a new matrix. Okay, now how do we do that? I'm going to show you. I don't know how you're going to write this down. You write it down however it makes sense to you. I'm just going to show you how it works. You go back to your original matrix here, and see where my fingers are?
Yeah.
Switch them. You switch them. So instead of having 1, 5, I'm going to have 5, 1. I switched those. Okay? So however you're going to write that down so you'll remember what you're talking about, you switch these two. Okay? Now, then you take these two, look where I'm pointing, and you leave them where they're at, but you change the sign of each. So this was a negative 1, he becomes a positive 1. This was a positive 2, he becomes a negative 2. Your answer then is 1 over the determinant times this new matrix. So it's 1 over the determinant. You got 7 when you did that. So it's 1 over 7 times the new determinant, or the new matrix, I mean. So that will be 5/7, negative 2/7, 1/7, 1/7. And that is your answer. The 1/7, remember, is like a scalar. It's a coefficient. We're just going to distribute it. So we take 1/7 times each of these. Okay? Now, there's no hard math in this problem, but I just have to remember how to do it. So, luckily there's another one. Let's try the next one. Kia, I need you paying attention before I come unglued here.
Okay.
No, thank you. All right, so what is the first step? I'm going to find the inverse. So the first thing I do is find the determinant. And the determinant will be 4 minus 0, which is 4. And then I'm going to build my new matrix. That new matrix, by the way, has a name. It's called the adjoint. You don't need to know that, just in case you're interested. The new matrix. Take these two guys right here and flip them. So you're going to have a 4 and a 1, right? Then we take these two and we leave them where they are, but we change their signs.
-0.
0 is 0, but this would become, wait, what did I do?
4, 1, 0.
I put that 1 in the wrong spot. So
Wait.
4 and 1 get switched.
That's a negative though, isn't it?
No. These two get switched, and these two get their signs changed.
Why?
That's the rule, Brittany. We just went through it here. We switch these two, and we change the sign on these
So if
two.
there's a negative, you just gotta remember just a sign.
Negative becomes positive, and positive becomes negative. Not these two.
So since you're eventually gonna have to multiply them, how come you have to flip those two? So it's not always multiply them. Since you have to flip the one.
Oh, no. The multiplication happens when you're finding the determinant.
Oh, okay.
Yeah,
I know.
no, we're gonna take that, it wouldn't impact the determinant, but that's not what we use it for. Now we're gonna take 1 over the determinant. We're gonna take 1 over the determinant times this new matrix that you made.
4 over 4, 3 over 4.
So we're not gonna write 4 over 4.
We're gonna write 1.
We're gonna write 1. And then 3 4s and 0 and 1 4. And that would be your final answer. Sean? Joni would not be happy. Okay. This is the answer right here. That is the answer. All right, I'm going to do one more with you, and then I'm going to set you loose on one by yourself. So let's walk through this way together. Here we go. Who remembers the first thing we do? Find the determinant. So 6 minus -4. Did you get 10?
Yeah.
New matrix.
3.
These two change places. That is a negative and that is a positive, but they stay where they are. So the 4 stays there, it just becomes negative. The 1 stays there, it just becomes positive.
Ah.
And then I'm going to multiply 1/10 times this. So I'll get 3/10, 1/10.
-2/5.
Now watch this, that's 4/10. That's going to reduce to -2/5. And the last one's 1/5. That's exactly right. So Kia, there's your final answer.
One more. Hey, one more.
One more, and you get to do it all by yourself.
Let's go. Let's go. Wait, what? There's 2 negatives.
Oh. They change up.
That doesn't have to change a thing. Just get started. Here we go. Wait, David says, wait. Our determinant is 0.
It's over.
Now, why does that matter?
You got to multiply with 0.
Because you're going to do 1 over the determinant, right? And can you do 1 over 0?
No.
It's not doable. There is no inverse for that problem.
Oh,
Let's go through that again.
you get 0.
The determinant worked out to be 0. In the process of finding the inverse, you do 1 over the determinant. You can't do 1 over 0.
It's undefined.
Exactly. So that means you can't find the inverse. Back up a few days. Do you remember solving systems of equations using substitution or elimination and getting answers that look like this or this? Those were the special cases, right? This one was no answer, and this one was they're the same line. What is going on here is, for problem D, you have a system of equations that says negative x plus 4y equals a number that I don't know, and 2x minus 8y equals a number that I don't know. Those numbers in the D problem that you just tried, those are the coefficients of a system. If you did elimination, just do it in your head. Multiply that top one by 2. What's going to happen when you add?
All X's and Y's.
They're gone. When you don't have an inverse, and when does that happen? When your determinant is 0, you got some weird thing going on. Either there's no solution or they're the same line. Don't know, but it's a weird situation. Okay? Easy. All right. Now we're ready for the calculator. Remember I told you there was going to be stuff? Okay, this is today. So we've got a few minutes left. Good. All right, so we're going to get our calculators out, and we are going to do these big problems with our calculator. It is very easy.
It's so easy.
But you have to
You know what? You know what?
have a calculator.
Mrs. O'Connor, whatever her name is. Kathy. I'm not being happy. Is it Kathy? Kathy. I'm not being happy.
Now, get a calculator out. Come on now.
She's not happy. What's moving Rob's name? I know this. I know. What?
Are you going to spray tan? Yeah.
What's your daddy's name? Anthony. We're not do that.
All right, so here we go. First thing I need everybody to do is look up here for a minute. We're going to do problem number 1. So we're on page 46, 7.3, problem number 1, which is a gigantic set of equations. Thank goodness you're not like poor little Lisa back in the day. We had to do that by hand using substitution and elimination, and it took a long time. You are lucky because you have a calculator. You're supposed to have a calculator. Here is what we're going to do. Write this down. You're going to write down the matrix of just the numbers in the problem. So 1, 1, negative 1, 2. That's the first equation. You see what I'm doing?
Yep.
Writing down all the coefficients. Leaving out the letters, leaving out the equal sign. So next we have 2, negative 1, 3, 14. Next we have 3, 1, 1, 14. Now is everybody with me so far?
Yes.
Okay. Now, you're going to do nothing except draw an arrow. The calculator is going to do everything. And it is going to produce a matrix, a new matrix from that one, that's going to give you the answer to the system. And the answer to the system will be not an ordered pair, but an ordered triple. You're gonna have an X, a Y, and a Z value. So instead of getting 1, 2, you're gonna get something like 1, 5, -7 or something like that, okay? So here's how we do it. Very, very simple, but you gotta do exactly what I say, okay? So here's what we do. Turn it on. You will notice in the first column of buttons on your calculator, the fourth one down, right under the math button, it says matrix. So press second matrix. Now, it brings up many options. I want you to use your arrow buttons and click across to edit. If you need to put numbers in, which we need to do, we need to give the calculator the numbers, you use edit. Now, I clicked over to edit, press enter. The first thing it wants to know is how big is the matrix you're going to put in. So how big is the matrix we're going to put in? 3 by 4. So we press 3 by 4, enter, enter. Okay? Now, did you notice it set up a matrix for you? And you're going to fill in the numbers now. So you're just going to type these numbers into the spots on the calculator. So put in the number and hit enter and watch which way it's going. So you're putting the numbers in the right spots. You just type them in and hit enter and it moves the cursor over for you. Okay, you got them in? All right. Now, we've got the matrix in, so we're ready to do something else, so we're going to quit this. So hit second quit. So quit is right next to second. Second quit, and that just takes you back to the home screen. Now go back into matrix, second matrix. Do not go over to edit because you already put in your information. Now you're going to go over to math. You're going to do something with the information now, okay? Now, what I need for you to do is arrow down until we get to a certain button. The button you are looking for, arrow down, you got to go quite a ways. You're looking for RREF. So I need you to arrow down until you find RREF.
Reduced row echelon form.
Reduced row echelon form. Yep, that's what it is. So you have to keep going down the list until you get to RREF. All right. Now press enter. Second matrix. Now it's highlighted on names A. Hit enter. So now the screen says RREFA. Press enter. And it produces a new matrix that looks like this. That should be the matrix that you came up with. Anybody come up with that? Now, what does that mean? Well, think about this for a second, kids. What did this say in the original? This said X plus Y minus Z equal 2. What does this say? X plus no Y's and no Z's equals 4. X equals 4. Y, remember, this is X, Y, Z. Y equals 0. And Z equals 2. So the answer to the problem is the ordered triple 402.
It's just those last numbers.
Yeah, I'm confused how you got that last one. Wait. I was listening.
They're right here. All right, so let's try the next one. See if we can get the next one done. So all you need to write down is the matrix that goes in and the matrix that comes out. So this time, the matrix that's going in is 1, 4, negative 2, 0, 2, 1, 1, 6, negative 3, 3, negative 5, negative 13. Now I gotta be real careful that I've got all my negatives because it doesn't work out very well if you don't have the right numbers. So this problem is going to be the last page of your test. You don't have to show any work except the matrix that you put in. And then eventually we're going to get a matrix out and our answer.
So I have a question.
All right?
When we put this into the calculator, do we have to clear it for a matrix?
Nope. Nope, you just type over it. All right, so here we go. So second matrix. And I'm going to go over to edit because now I have some new numbers to put in, right? And again, it's a 3 by 4. There's already numbers in my calculator. Now I don't care, I just type on top of them. Just type right over them. So I'm going to put in my new numbers. Got all my new numbers in. You remember what you do after you get all the numbers in? You second quit, get out of there. You're done there. Then go back in the second matrix. Go over to math, and then all the way down to RREF. And then what? Second matrix, enter. And this answer,
That's fraction.
that's okay.
Deja Collins to the front office, please. Deja Collins.
So this one is 3,
Taylor Hollingsworth to the
negative
front
1
office,
half,
please.
1
Taylor
half.
Hollingsworth, please come to the front office.
Is that what you got?
Yes.
After you put the numbers in, you do second matrix.
Yep.
And then you go to name.
Nope,
No,
over to
go to
math. Over to math,
And then what?
down to RREF. And then second matrix, names, enter, enter.
I leave the calculator in here last time I took the test.
I am going.
Poppy.
What kind is it?
Morning.
Name on it by any chance, or is there any kind of a difference?
Very scratchy about it, you remember?
No, you're not.
Dylan, would you hit the video off?
That's right. Sweet.
All right, everybody.